So this one is the 3-jaw shaft lathe machine. 3-jaw shaft lathe machine, it is a self-centered. So there are different parts of the lathe machine. I'll show one by one. So this one is the headstock. There are different parts in the headstock. This one is the shaft, 3-jaw shaft. This one is the tool post. This one is the carriage. This one is the cross slide. This one is the tailstock. This one is the tool post, and this is the cutting tool. It is clamped into the tool post. This is the cross slide. We can move front and back of the tool post. This is the carriage. We can move right or left to the tool post, and this is the cutting fluid pipe. Here we can apply the cutting fluid at the interface of the tool and workpiece, so that the extra heat is carried away by this cutting fluid. And this one is the lead screw, and this one is the lever for the setting of the RPM of the spindle. So according to the different position of the lever, we can set up the required RPM. So here if you see, it is at the J position, this, and if you see now it is at K position. So now it is K position, and if you see this one is at P position. So that is a JKP, that is the RPM is 240. So accordingly setting up the different engaging or disengaging. So in our first experiment, so we have, our objective is to face, turn and chamfer. So facing operation, as already I have told, so this is the tool, it is at the 90 degree or it is parallel to this face of the workpiece, and this is called turning operation. This is at 90 degree to the workpiece or it is parallel to the axis. So it can move either through this part, that is left, or right part it can move. And this part, it is called chamfering. This workpiece, that means we use some angle to make some degree it is given. So this process is called chamfering, that is making some angle, tapering like this. So it is called chamfering. This is the finished part of this workpiece. So here there are 3 operations. One is turning operation, one is facing operation, and one is chamfering operation. So for this, what we have to do, we need one workpiece, one cylindrical workpiece. So here it is shown, the cylindrical workpiece. The cylindrical workpiece, the length it is shown here 110 mm, and diameter of this workpiece is 50 mm. So we have to reduce the diameter. So first what we will do, we will face this face of this workpiece, then we will start the turning operation. First we have to reduce the diameter up to 40 mm, because this side we require 40 mm. Then up to turning 40 mm length, then we have to reduce the diameter here to 20 mm. So this part, the tool travel this side, this is called the turning operation, and this part where we are doing the to smooth or plane, to properly plane, we are doing the facing operation. And this, whatever we have seen, this one, this part, it is some angle to this face. This is called the chamfering operation. So in a workpiece using lathe machine, we can do various type of operation. In this experiment, we have performed turning, then facing, then chamfering operation. So finally we can obtain the workpiece size of like this. So we can do various types of workpiece, that means cylindrical workpiece of different dimension, using this operation in the lathe machine.